Hello, welcome back once again. Today we have this interesting equation. It is a transcendental equation. And we're going to solve for the value of s using the Newton's method, right? The first time I'm using this method on my channel. So it's going to be awesome, okay? So we have 2 raised to the power of x plus x is equal to 5. Of which you can still write this equation as 2 raised to the power of x plus x minus 5 is equal to 0, okay? So let's define the following function. Let's say we have f of x is equal to 2 raised to the power of x plus x minus 5, okay? So we're going to check the following inputs. So let's compute f of 0. So f of 0 is going to be equal to 2 to the power of 0 plus 0 minus 5, right? So this is going to be equal to 2 raised to the power of 0 is 1 plus 0 minus 5. So this will give us negative 4. So let's check for f of 1, okay? So f of 1 is going to be equal to 2 raised to the power of 1 plus 1 minus 5. So this is going to be 2 to the power of 1 is 2 plus we have 1 minus 5. And obviously this is equal to negative 2. So let's check for f of 2, right? So f of 2 is going to be equal to 2 raised to the power of 2 plus 2 minus 5. So this is going to be equal to 2 to the power of 2 is 4 plus 2 then minus 2. So obviously this is equal to 6 minus, minus 5, right? So sorry for that. Okay, so minus 5 here. So we have 6 minus 5, which is equal to 1. Did you realize something? You can see that the sign changed from negative to positive, right? So check the inputs. Remember, this f of 1 gives negative 2, which is negative, right? Why f of 2 give a positive result? So this shows that our solution lies between 1 and 2. So we can say 1 is less than x and x is less than 2. Did you get the idea? So here we're going to choose a number between 1 and 2. But before that, take note, here is the Newton's formula. So x with subscript n plus 1 is equal to x with subscript n minus f of x with subscript n, then divided by f prime, that is the derivative with subscript n. So you get the idea? So you can see that we need f of x here, and we also need the derivative of that function, right? So already we have our f of x. So our f of x is equal to, that is 2 raised to the power of x plus x minus 5. Therefore, the f prime of x will be equal to the derivative of 2 to the power of x will give us 2 raised to the power of x multiplied by the ln of 2. Then plus the derivative of x is 1 minus the derivative of 5. 5 is a constant, so that will give us 0. So this is the derivative of f of x, right? Okay, cool. Now we're going to choose a number or a point between 1 and 2, since our solution lies between 1 and 2. So let's pick the point 1.5. okay, so let's just start with that. Okay, now remember our formula, that is xn plus 1 is equal to x of n minus f of x of n, then divided by f prime of x of n. Okay, okay, so from here let n equals 1. So remember that this is x1. Sorry, I didn't put that earlier. So if n is equal to 1, so we get x of 2 is equal to x of 1 minus f of x of 1 right? Then divided by f prime of x of 1. So we need to compute f of x of 1. So f of x of 1 is equal to f of 1.5, because that is x subscript 1, right? So this is going to be equal to 2 raised to the power of 1.5 plus 1.5 minus 5. And with the help of my calculator, so this is approximately equal to negative 0.671572.875. Then we need to compute f prime of x subscript 1, which is equal to f prime of 1.5. So that will give us 2 raised to the power of 1.5, right? Multiplied by the ln of 2, then plus 1. So this one here is approximately equal to 2.960516.287. So we're going to substitute now. So we get x of 2 is going to be equal to x subscript 1, which is x of 1. So that is going to be 1.5. Then minus f of x of 1. So that is, let's put in brackets, negative 0.671572.875. So divided by f prime of x subscript 1. So that is 2.960516.287. So this is going to be equal to, remember we have minus times minus, that will be plus. So we have 1.5 plus this division here. So with the help of my calculator, this one right over here is approximately equal to 726, I mean. So you know the beauty of this Newton's method. If you have this type of equation, you can just use all this basic calculator. Once you're with your calculator, you are done. You can get the nice approximation for the value of x. But with the Lambda-W function, you will need something like Wolfram Alpha, which will look for a device like phone to approximate. Okay, so this is 2,6 here, and then we have 843, and then we have 162. So this is our x of 2. Then our x subscript 3 is going to be equal to the x of 2 minus the f of x of 2, right? Then divided by the f prime of x of 2. So here x of 3 will be equal to, so x of 2, that is 1.726.843.162. Then minus, so if you check, remember that f of x is equal to 2 raised to the power of x plus x minus 5, and f prime of x is equal to 2 power x ln of 2 plus 1. So if you check f of x subscript 2, that is letting x equals this, so this one right over here is going to give you 0.0368 705 6766. So divided by f prime of x of 2, so that one there is 3.294336.16381. Okay, so with the help of my calculator, x subscript of 3 is approximately equal to 1.7156511. So you can see that the value we got earlier is a little bit bigger than the value we got for x of 3. So let's continue going. So for example, let's say we have x of 2. Let's say we're solving an equation and we have x of 2 is equal to 1.05. Then we get s of 3 again as 1.05. We still continue and we get x of 4 as 1.05. So this is telling us that this is our solution. So this is the good level of the accuracy for the approximate value of the equation. Okay, so let's continue moving. So let's say if x of 4 will be our final bus stop. Okay, so our x of 4, remember from the formula, is going to be x of 3, the previous one, minus f of x of 3 divided by f prime of x of 3. So here x of 4 is going to be equal to, this is 1.7156511 minus, so when you input x of 3 into the function, so we get, wow, 0.00009499907 divided by f prime of x of 3. So that one will give us 3.276606 So here we get x of 4 is approximately equal to 1.71562073335. I think we have almost the same value with x of 3, right? So here we can easily approximate our answer as 1.716, right? 7156. Okay, so in the above equation, 2 raised to the power of x plus x is equal to 5. So with the Newton's method, we find out that x is approximately equal to good 4 decimal places as 1.7156. So this right over here is our solution. Thank you for watching. Please, if you really enjoyed this video, please kindly subscribe to my channel. Also like, comment and share.